Jasmine Gutbrod, and I'm one of the 4 artists here this month. So I consider myself in this pretty common in this place intersection between art, design, outdoor education, and nature culture sustainability. In all of these fields I've studied and practiced in various capacities. I want to point out some written research that I've done recently as part of the MA thesis in art and design education, and it's really looking at how what being an art educator looks like today with all of these climate issues and social justice issues, and how art educators can be a facilitator between these conversations. Oops. So thinking about our era as the Anthropocene, and thinking about what's a classroom today and how outdoor classrooms can facilitate these conversations between nature and culture. And at the end of the day, I also make objects. So I studied furniture design, and that led into investigations with sculptural medium. So this is a lamp that I made, and one of the things that I like about designing objects is that it is very based in materiality. So I like designing objects that are ambiguous on whether or not they are supposed to be for inside or outside, both literally or conceptually. So this lamp is made with just paper and steel, so I welded this steel frame. And then the outside is basically just advanced paper mache, but it makes this really beautiful membrane with a really thin light bulb in the center. And then it's difficult to see in this photo, but I purposely rusted the steel so that there's this really bright orange coloring that leaks into the paper around the edges, and then I sealed it. So I was thinking about this process of decomposition and how we could bring that into the home. This bench is called hay bale bench, and similarly thinking about materials and how with furniture and construction, I think the tendency is often to cover up the materials and hide where the source is from. But at the end of the day, everything that we use is somehow related back to the earth, whether or not it's plastic originally from petroleum, or whether it's from wood, which once grew in forests. So this bench is thinking about how you can relate back to that original material and the earth where the materials are sourced for the objects around us. This was a little bit of a shorter term project called Blueprint by Worms, and it was inspired by research that came out several years ago through Stanford, and they were looking at mealworms and how they can chew up styrofoam and digest it safely, which was really cool because, as you guys know, styrofoam is very hard to recycle, lasts a very long time, and the chemicals are quite toxic. So mealworms have this remarkable capability due to gut microbes in their intestines. So they can chew right through styrofoam, and it doesn't harm them. So if you have reptiles, you can actually still use mealworms as feeder insects without harming your pets. And in this experiment, I also offered them oats. So I basically had a container of styrofoam and maybe about 300 mealworms, and then mixed in with the styrofoam, I just had dry oats to supply supplemental nutrients. And the presence of oats had no effect on whether or not they still wanted to eat the styrofoam. And here on the right, that's actually clear tape that they chewed through. So they're really good at digesting plastics. And what I did is I had these measured cubes of styrofoam placed into their enclosure, and then over the course of about 3 weeks, they would chew through the styrofoam blocks and create these little houses for themselves, made of tunnels and cavities. And so I used those blocks that they created as block prints, and then I was experimenting with the block prints that they made, and then made these orthographic drawings of their abodes. So this is a fun project, and it's also something you can do at home. Sort of like shifting away, I also have a ceramics practice that looks at both object and texture in interesting ways. One of my personal interests with the natural world is studying different textures. So this is on the left is a completely ceramic chair. It's very heavy and somewhat impractical, but it has this texture on it that I then applied to some other objects as part of this series. This is me in the studio spraying on the glaze. And then, so the previous ceramics, these are all hand-built, and I used like a clay extruder, sort of like a big garlic press to create the texture and then applied it on by hand. But recently I've been experimenting with 3D printing of clay, which also allows me to get really beautiful texture, but in a more precise way. And what I like about this process is that the malleability of the clay is very imprecise, but the pursuit of the precision through 3D printing reminds me of the way things in nature are built with order and pattern, but they have flaws, and you have to work with the flaws that arise. So these are some of the vessels that I've 3D printed. These are porcelain. And then the cool thing about clay and 3D printing is that you can mix in different pigments. So the bottom, I mixed in orange pigment, and then as it's extruded through the printer, it creates this natural gradient as the clay that I mixed color in runs out and transitions back to the natural clay. So just an example of textures that I look at when I'm thinking about my designs. On the left is a scanning electron microscope image of a diatom, which I love this image because it's so hard to tell the scale. To me, the diatom looks like a tiny coliseum. It's just very architectural, and it looks like this fallen relic, but in reality, it's like this very, very tiny structure. And then lichen and coral, of course. And I'll just play a video of, so this is right after I've loaded the clay and extruded it, this is what one of the pieces looks like. That sounds my printer as it moves across. So I designed these digitally through a CAD software, and then one of the tricky parts is that you have to account for the viscosity of the clay in your solid object design, which takes a lot of trial and error, but it's one of the things I love about the process because you never know quite what you're going to get until you print it. And then more in the design aspect, I also worked on this project. It was a collaboration with an engineer and a couple scientists in Panama, and we were looking at portable microscopes and how to create low-cost scientific equipment. So this was more of a design project for me, so we're figuring out how to fit all these little components into a pelican case that we could just pack up and bring into the jungle and conduct microscope research on the site. And we used an open flexion microscope, which is an open source microscope that you can 3D print, and we used just a lens from an old compound microscope that was broken. And it has a little LCD screen and a camera module so that you can take images of what you're looking at and store them and label them on site. And then it also has like a huge battery underneath this platform. There's places to store test tubes and eyedroppers. And since, what day is it, Tuesday? So the past couple days, I've been going out with Haley and her owl team, which has been so magical. And I've just been thinking about all the information that I've learned the past couple nights with the owls, and thinking about the different markings and how all of these owls are the same species, but they all look so different from each other and have these wonderful varying characteristics. So I'm just thinking about how that might inform a project soon here, whether it's for direct science communication or for something more conceptual. I'm not sure yet, but yeah. Thank you so much. If you have any questions, let me know. I'd also love to hear what all of your projects are eventually, so through some of my image sources. Oh, yes, question.
So is it like a special 3D printer for clay, or do you modify regular?
So you can yes and no. It's a custom built printer, so you can actually buy clay printers off the market, but they're very expensive, like $3,000 to $6,000. And this one only cost me about $800 to build. And what I did was I bought a custom extruder head from a 3D printing clay company, and then I just adapted it to an existing Delta printer. So the actual printer base I have is just like a normal PLA printer base, and I just took off the heating element and nozzle and switched into clay extruder. And then my printer basically works with, there's a couple different styles you can do. Some are motorized and use just like a big auger screw at the top. Mine uses an air compressor to push the clay through the system and uses some acrylic tubes to hook it up to the nozzle. And what I like about the air compressor is that it makes it easier to stop and start the clay. So while I'm printing, sometimes you get air bubbles that build up in the system. And if that comes out in the piece while you're printing, it creates like a big cavity, a little explosion. That's no good. So in some of the designs for 3D printers, it's very difficult to stop because there's so much built up pressure in the clay, it just keeps squirting out. With the air compressor, there's like enough distributed pressure that I can stop the printer, move it to the side, extrude out the air bubble, and then continue printing without ruining the piece. There's a couple other benefits, but that's basically, if you have any like more specific questions, I can go through it with you. Great, thank you so much.